The field of isotope production is a very exciting frontier. We have so many opportunities to produce radioisotopes that can help people every day.
Today, 8 national laboratories are included in the DOE Isotope Program's activities, and we are enhancing the capability by integrating universities in order to establish a network of production sites across the nation, including the DOE complex as well as university capabilities.
Our portfolio consists of isotopes for academic, medical, and industrial applications. Strontium-82 is our major isotope in production. This is a diagnostic isotope used for cardiac imaging. And we've been producing this isotope for approximately 20 years with increasing supply every year.
As strontium-82 potentially moves into the commercial sector, we have a real opportunity to have more beam time available here, both at Los Alamos and at Brookhaven National Laboratory for research and development.
We have several initiatives. One, of course, that is guided by the recommendations of the Nuclear Science Advisory Committee report, is trying to enhance the availability of alpha-emitting radioisotopes that can be used to treat cancer, the various different types of cancer. Under this initiative, we are establishing and increasing the availability of actinium-225, astatine-211, and the lead-212 generator system. And besides the alpha-emitting radioisotopes, we also re-established the production of copper-67.
Actinium-225 is a short-lived radioisotope. It has a half-life of about 10 days, decays via alpha emission. It is an isotope of interest now in the medical community for targeted alpha therapy applications. And here at Oak Ridge, as part of a joint tri-lab effort between ourselves, Los Alamos National Lab and Brookhaven National Lab, we're producing it, and at Oak Ridge we are chemically separating it from a thorium target from which we are making it from, purifying the material and shipping it out to end users for evaluation.
We feel that we can use the U.S.'s high energy accelerators to produce in roughly 10 days the world's annual supply.
Once the supply is there, actually the future is wide open for application of this because it can target so accurately to cancer.
For the project right now, we are working on more fundamental knowledge of actinium, and in the future we would like to work more in biological relevant media so that we can actually know how actinium will react in your body.
The production of astatine-211, which is another alpha-emitting radionuclide, is a promising candidate for cancer treatment which requires unique capabilities for its production. Astatine-211 is an isotope which we want to produce at the universities, so we are integrating the universities who have the unique capabilities to produce astatine-211 into our network of DOE production sites.
Here at Oak Ridge National Lab, we're supplying lead-212 in the form of a radium-224, lead-212 generator, and we run a series of campaigns, usually about one per month right now, to separate radium-224 from its parent, thorium-228. We then take the radium-224, we load that onto a generator, we send that out to the customer, where they're using it for a variety of applications and R&D, and they will periodically milk the lead-212 from that generator and use it in targeted alpha therapy applications.
Due to its biological and chemical properties, copper-67 attracted great interest in the 90s. So we now are re-establishing the availability to continue the critical medical research, and for that we developed the production at our proton accelerator at Brookhaven National Laboratory, as well as we are in the process to bringing online the production on the electronic linac at Oregon National Laboratory.
I think working with radioactivity is very exciting, especially in the application of medical use. There are so many different opportunities that can be obtained using radioactivity in the treatment of cancer and various other diseases, and also imaging. And I believe that the full potential has not been tapped and that this field is only going to get larger. So it's a very exciting time.
To see this research translated to medical applications feels very gratifying, that to know my data can be useful to someone. I'm very proud to be able to work on this project.
Ultimately, these materials have an end use, and that they will be involved in the treatment of cancer. And if you can come to work and help make a difference in those fields, then it's really rewarding.
Everybody knows someone who has had cancer, or people in my family have had cancer. And so it's very exciting to be working on a treatment method that could make a difference in their lives.